So I have here the two last examples on the differentiation of algebraic functions. We have find the slope of the tangent line y equals x squared minus 1 at the point at the point 2, 3. Okay, at the point 2, 3. Ibig sabihin, specific, ang pinapakuha sa ating slope ay dun mismo sa tatamaan ng ating function na y equals x squared minus 1 sa point niya na 2, 3. Okay? So, what we're going to do is to determine first the derivative of the function. Kasi yung derivative ng function na to will determine doon sa slope niya at that point 2, 3. Kasi yung makukuha nating derivative, yun na yung slope of the tangent line. General slope, okay, of the tangent line. So, kunin natin yung derivative. So, we have y equals x squared minus 1. So, dy over dx. O, madali ito. Derivative ng x squared is 2x. Derivative ng 1 is 0. So, ito yung pinakang slope of the tangent line. Any point doon sa curve. This is a parabola. So, ibig sabihin, ganito siya. Ano ba to? Okay, we have, yung graph nito ay, transpose natin yung 1. So, we have y minus 1 equals x minus 0 squared. So, therefore, ang vertex niya is located as hk, 0, negative 1. So, ang graph niya ganito. Tatama sa 0, negative 1. So, we have 1, okay. So, we have at 2, 3. 1, 2, 3. Let's say ito yan. Okay. So, aalamin natin kung anong slope dito. Ang ating tangent line. Yung ating tangent line, kukunin natin yung slope niya. Pero ito yung slope na mismo nung ating parabola. Any point dun sa ating parabola. But specifically, ang pinapakuha sa ating slope ay at 2, 3. So, anong slope niya? So, ang slope niya is m. Yun ang ginagamit nating notation for slope is also equal to your dy over dx. So, at 2, 3, ano kanyang slope? So, just substitute the value of x, which is 2, to x of our dy over dx. So, 2 times 2, which is 4. So, therefore, ang slope niya at 2, 3 is 4. Steep siya. Okay? Ito siya. Ang slope dyan ay 4. Okay? At siya yung tinatawag natin dy over dx. Okay? Yung derivative, sabi natin, responsible yan sa pagkuha ng steepness ng ating function. Okay? Now, last example, number 11. Find the values of x for which the derivative is 0. Yan, derivative is 0. Napakahalaga nito sa topic ng calculus natin. Kasi kapag ang derivative is 0, doon nag-occur yung ating maximum at minimum point of the function. At napakaraming applications ng ating derivative when the derivative is equal to 0. Okay? And later on, I'm going to discuss that to you. But for now, what we're going to do is to determine the value of x, which is wherein the derivative is 0. First thing to do is to determine the derivative of the function. dy over dx, derivative of x to the 4th is 4x cubed. Derivative nito, 3 times 8 is negative 24. Decrease the power of x by 1. Square 2 times 22 is 44x. Okay? And then 1 times 24 is negative 24. And derivative of 9 is 0. Now, ano daw yung value of x wherein the derivative is 0? So, equate lang natin to sa 0. Okay? Then, common monomial factor is 4. We have x cubed minus 6x squared plus 11x minus 6. Yan. So, factorin natin to. Paano natin pa-factor yan? So, by synthetic division. Okay? Ano ba yung mga factors nito? 1, 2, and 3. So, yun ang gagamitin natin in synthetic division. Dapat ang device ang ating output of the last column ng ating synthetic division is 0, which means remainder is 0. Ito yung ating remainder theorem, okay, ng grade 10. So, we have kunin ng mga coefficients. We have 1, negative 6, 11, negative 6, So, from the constant, doon tayo kukuha ng mga pwede nating multiplier sa ating syntactic division. Pwedeng 1, 2, and 3. So, umpasahan natin sa 1. So, 1, bring down 1. 1 times 1 is 1, negative 5. Negative 5 times 1 is negative 5 here. We have 6. 6 times 1 is 6. So, we have 0 remainder. So, ang factor natin, ito yung una, x minus 1. We have x squared, decrease the power of x by 1. We have minus 5x plus 6. This is your equal to 0, right? So, we have 0 here. X minus 1. Factorable pa to. X minus 2. X minus 3. So, ano yung mga values of x wherein the derivative is 0? We have 1, 2, and 3. We equate all the factors to 0, resulting to x equals 1, x equals 2, and x equals 3. So, yun yung mga values of x wherein our derivative is 0. So, that will be the end of our lesson about differentiation of algebraic functions. So, thank you.